Okay, so we are looking at an iodine thiosulfate titration calculation. This one is on page 1862 of our red book. Normally in the titrations it would just be the information for your table would come from iodine and thiosulfate, but if you can remember, iodine is a non-polar molecule. If you do the electronegativity difference, it is going to be equal to 0, and that then suggests that it will not be soluble in water and will be soluble in organic solvent. Yet up here, when we're doing it, we are doing it in water, in aqueous solution. So because of that, you are aware that we liberate the iodine from in our conical flask, putting in some KMnO4, we put in some sulfuric acid, and finally we put in some Ki. And when we are doing this, our Mn7 plus is being reduced to Mn2 plus, and here our I minus is being oxidized to iodine. The great thing about this is that usually our Ki is in excess, and instead of actually forming iodine, it forms I3 minus ions, which behave in the exact same way as iodine does, but more importantly, this is soluble in water. So if technically we were being very correct, up here we would have this as I3 minus, but we don't, because it's behaving like iodine, so therefore we are going to call it iodine. So normally the titration maths questions would be very simple. You would be looking at iodine against thiosulfate from our tables, but as you can see here at the bottom we have two equations. So this one here is making the iodine or liberating the iodine in our conical flask, and this equation at the bottom is our titration. So you have to work out what the ratio is for the relationship between KMnO4, between iodine, and between sodium thiosulfate. So before we look at anything else, we look at our ratios. So here I have changed 2 KMnO4s, and that gives me 5 I2. So that is a 2 is to 5. And then if I look at my second equation, it's the iodine at the end. I want to link it to the iodine at the beginning. But the iodine at the beginning is now only 1. So if I have to turn that into 5, what does that do to my thiosulfate? So I'd have to multiply the two equivalents of thiosulfate that I have by 5 to give me 10. So my ratio in this instance is 2, 5, 10. And you may need to be able to do that, or on a really good day, they're going to give that to you in a question, and that would be brilliant. I didn't mean to delete that, so apologies. Okay, so we now go and look at the rest of our question. To figure out what went in our attic, we're looking for the number that is not the whole number. So if we peek here, we have 22.45, and this is our solution of thiosulfate. So 22.45 centimeters cubed. If we have a scoot down through our question, we can just see down here, we're trying to find the concentration of sodium thiosulfate. So this is going to be our question mark. We then have a look at the other numbers that we have in our question. So going up to this first line, we have 25 centimeters cubed of 0.022 big M. And if you scan down through, there are no numbers for the iodine, and that's okay. So as we've said, always you do your W. So we start, this is going to be our way in here. So when we start here, we have moles in 1,000 centimeters cubed. We go down, and when we go down, we're going to divide by 1,000 to find out what's in 1 centimeter cubed. We're going up here, so we're multiplying by our titer volume for the KMnO4 in this instance. And at this point, we're going to use our ratio. And normally we only have two things in our ratio. So this would be the KMnO4 over here. And usually this would be our thiosulfate over here, because they're the numbers we have. But actually, when we get to this flat point, we can work out how many moles of iodine were actually liberated and are present in our vessel. So it's got this extra little thing that we can do, and you just need to be aware of it. So again, once we find our moles of iodine at our titer volume, we're going to divide that by our titer volume, and it's going to give us moles in a centimetre cubed. And then finally, to finish off, we're going up. When we go up, we always multiply by 1,000, and that's going to give us our moles in 1,000 centimetres cubed. Okay, we may need our mass triangle, so that is going to be moles mass divided by molar mass. And as I say, we always do our W and our mass triangle first, and then we see where we're at the end. So we start with our way in, the 0.022, and this just means 0.022 moles in 1,000 centimetres cubed. So the first thing I'm going to do is divide my 0.022 by 1,000, and when I do that, I get 2 by 10 to the minus 5 moles in a centimetre cubed. So we've just gone to this point of our triangle. We then multiply it by our titer volume, which is 25, and when I do that, I get 5.5 by 10 to the minus 4 moles in 25 centimetres cubed, and that, as we say, is our titer volume. So that's gotten us up to this point now in our W. So there are 3 things we can do here in terms of our using our ratio. So apologies, it's time for school. So we know from our maths that we have 5.5 by 10 to the minus 4 moles at our end point here, and that is equivalent to a 2. We know the ratio is 2:5 is to 10. So to figure out how many moles of iodine I have, I can go 5.5 by 10 to the minus 4. I can divide that by 2 and multiply it by 5. So I'm going to scoot this out of the way for now. And when I do that, I'm going to get 1.375 by 10 to the minus 3. And finally, our Na2S2O3, it is going to be 5.5 by 10 to the minus 4 divided by 2. And I'm multiplying this by 10. Alternatively, you could multiply this number by 2 because it's 5 is to 10. So whatever way it's going to work for you, please do that. So when I do this finally, I am going to get 2.75 by 10 to the minus 3 moles, and that is in 22.45 centimetres cubed. That is our titer volume. So with just using a ratio, this was the moles of KMNO4 over here that were required to liberate this much iodine in our flask, and this much iodine reacted with this much sodium thiosulfate. So now we are over at this point, and we've gone through this point. So our last little bit is to 2.75 10 to the minus 3. We're going to divide that by the titer volume to find out what's in 1 centimetre cubed. To the minus 4 moles per centimetre cubed, and then finally to turn that into a big M value. So in our W, we just got to here. So we're going to multiply this by 1,000, and when we do that, we get 0.122. I'm going to stop at 5. So if you look at our data table up here, we have 4 significant figures. So unless I'm told otherwise, I'm matching this to 4 significant figures down here. Now, we will then use our mass triangle. So we're trying to find moles of sodium thiosulfate, and to do that we just need to find the molar mass of sodium thiosulfate. So again, you always show your examiner all of your numbers and all of your working out. You don't be afraid to do that. If you get the number wrong because you've just put in a final answer, you get no marks, you lose 3 marks. But if you have all of these numbers correct and you just inputted this one incorrectly, then it's called a slip, so you only lose 1 mark. So our last little bit of this is going to be taking .1225 by 158, and when I do that I get 19.35, and again this is going to be in 4 significant figures. So we talk about annotating. So if you go back up, we have a look up here to read what we have to do. How many moles were present in 25 centimeter cubed of your 0.0022 moles? So that is this answer here. You don't have to box anything, annotate anything, as long as your examiner can follow it down. You just have at it. The next question here, how many moles of iodine were liberated in the reaction? Well, that's this answer here. Hence, identify the concentration of sodium thiosulfate in moles per litre. They're asking for here, and in grams per litre. So this is our moles per litre, and this is our grams per litre. And now we just check, have we done everything else? And it wants also grams per litre of crystalline sodium thiosulfate with 5 waters of crystallization attached. So whether or not this would be asked in a proper leaving cert question, I don't know, but we will give them to it. So we know, we know that the sodium thiosulfate is 158 by itself. So now we have to add 5 H2Os to it. So please remember, in this method, 5H2O, it is 5 H2s, but it's also 5 O's, because sometimes that can get lost in the mix. So we're adding 1 by 10 and we're adding 16 by 5. And when we do all that, we're going to get 248. So to finish it off, 1.225 by 248 is going to give me 30.38 grams per litre, because it's 4 significant figures. Okay, so organization, really, really important for this. Understanding how we get this ratio and how it can be applied. It's okay that there's nothing here and here, so we never know a volume and we never know a moles in 1,000 centimeters cubed, but we can work out the moles at the end point.